Video 3, Interpreting Item Parameters. Roadmap, where we've been. The first video we looked at the user experience. In the second we answered the question, why would intelligent tutoring software use IRT? Now we're going to interpret item parameters. And where we're going later, in video 4, is putting these item parameters into action. Alright, item response theory vocabulary. Keyword number 1, parameter. In non-technical terms, think of this as variable or characteristic. In a one-parameter model, items are only different from each other in one way. The next keyword speaks to a way that items will be different from one another. Item difficulty. How proficient does an individual need to be in order to have a 50-50 chance of responding correctly to the item? Another way that items can be different from one another is in their discrimination. An item discrimination parameter tells us how effectively this item distinguishes between more and less proficient individuals. And proficiency, as we discussed before, is a person's knowledge or expertise in a given domain. The next word is IRT model, and we build a model using item response theory to explain patterns of correct and incorrect answers. We assume that students answer items correctly because of their proficiency in the domain of interest. More specifically, we're assuming that the only reason that students answer items correctly is because of their proficiency in the domain of interest. We know that in reality, the phenomena that explain why every single student responded the way they did to every single item is more complicated than our model. The simplest model we'll look at is called a one-parameter IRT model. In this case, we fit a model that assumes that all the items are equally discriminating. The one parameter we estimate, and the one way that items differ from one another, is difficulty. This is an item characteristic curve that would come from an IRT model. The idea is that item parameters determine the shape of the curve. And so this curve graphs the probability of a correct response on an item by an individual's proficiency. You can see that proficiency score is on the x-axis and probability of a correct answer is on the y-axis. So if we want to set a proficiency score of -2, for example, we can find that the probability of answering the item correctly is about 0.12. Another way to get information about this curve is to say, well, how proficient would someone need to be in order to have a 0.7 probability of answering the item correctly? So we can draw a kind of squiggly line down from where the curve intersects 0.7, and we can say, okay, someone would need to have a proficiency score of approximately 0.75 in order to have a 0.7 probability of responding correctly to the item. Let's look at two item characteristic curves from a one-parameter model side by side. So you can see here we have two items and one is more difficult than the other. The red one is more difficult than the blue. The curve is just shifted over to the right, which is where the term item location comes from. Just like we did on the last slide, we can say, okay, for someone with a proficiency score of -2, what's the probability that they're going to get the red item correctly compared to the blue? For the blue item, we can see that it's about maybe 0.27, and for the other item, we can see that it's about 0.05. Thinking back to our geography example, the blue curve could represent an item like Chile on the geography test. Someone with a fairly low proficiency score like -2 may only have a 0.27 probability of being able to identify Chile on the test. If we assume that it might be harder to identify Nigeria than Chile on the map, then we could say that the red curve represents an item like Nigeria, where someone with a -2 proficiency score may only have perhaps a 0.05 probability of identifying it correctly. Previously, I defined item difficulty in terms of the proficiency score that an individual needs to have in order to have a 0.50 probability of answering the item correctly. So we can come on over to the y-axis and circle the 0.5, and then walk over to the blue curve and see exactly at what proficiency score the blue curve intersects the 0.5 probability. And here it looks to be a little bit less than -1. Now let's look at what happens when we change the discrimination parameter on our item characteristic curves. You can see that these two items have the same difficulty. An individual needs a proficiency score of about 0.5 in order to have a 0.5 probability of answering the item correctly. The difference between these two curves is the value of the discrimination parameter. Let's look at some other two-parameter item characteristic curves. They can look like this, where the green item is a lot more difficult than the red item, or they can look like this, where the green item and the red item have the exact same difficulty parameter, yet one is far more discriminating than the other. A higher value for a discrimination parameter will mean that an item is more discriminating when it's at its steepest point. It doesn't mean that it's always steeper. As you might recall from algebra, slope equals rise over run. In this case, we're interested in slope because it tells us about discrimination, and a steeper slope means that the item is more discriminating at that proficiency level. As you can see, the curve is not equally steep at every point. Let's look back here at -0.5. We can look at how much the probability of a correct response rises as we move horizontally from -1 to -0.5. And we can look at that little triangle that gives us a sense of how steep it is at that point. And then we can pick another point on the curve. For example, let's go up to 0.5. And let's look again, let's move about 0.5 horizontally. That's our run. And let's see how much the probability of a correct response rises during that same horizontal distance. And here we can find that it's a much, much steeper change. Let's do some practice together. Let's draw a curve for an item that's very discriminating and also very difficult. So let's start with figuring out very difficult. So we said more difficult is over here to the right. And so maybe let's say that very difficult means that you need to have a proficiency score of 2 to have a 0.5 probability of answering the item correctly. As for discrimination, we know that a more discriminating item is going to be steeper. So we also should start drawing a pretty steep curve right here. Something worth noting is that while it's really steep, this curve, between maybe 1.5 and 2.5, it's not steep at all past this point. So if I were to draw this farther out to the left, it would be pretty much flat. This means that it would be a lot more discriminating among people with high proficiency scores in that, range around 2 than it would be for people with low proficiency scores. Let's go back to the geography example and do a few more. What do you think the item characteristic curve would look like for Italy? I'm thinking it would be probably one of the easier countries in the world to identify. So even people that aren't terribly proficient in their knowledge of countries of the world could still have a reasonable shot of getting Italy correct. It's not obvious to me exactly how discriminating Italy would be, but I suppose that it could be a good way to differentiate between people who know very, very little geography and who know a little bit. It also makes sense to me that the line would get pretty flat once you get into proficiency scores at or above 0, assuming in this case that 0 is about average. I guess I would expect that, maybe about 97% of people with above average geography knowledge could correctly identify Italy on a map. But Vatican City is another story, especially if you thought that you were supposed to be identifying a country based on the location on the map. It's really not clear to me how good of a job this would do at differentiating between people who have a lot of knowledge of geography and who don't have a lot of knowledge of geography. It seems that people could get confused. It seems a little bit trivial to know that Vatican City is technically a country. So let's assume that in order to have a 0.5 probability of answering correctly, you need to be kind of a geography whiz. You need to really be into this stuff. I'm talking, theta score of 2.5. And then in terms of how discriminating it would be, I would think it wouldn't be terribly discriminating. I don't think that whether or not you answer this item correctly is going to give me a lot of confidence in determining whether you have a proficiency level of 2 or a proficiency level of 0. All right, I hope this makes a little bit of sense. Next, we're going to shift gears and look at the math a little bit, what's going on under the hood. If you're really not into the math, don't worry, we're not going to spend long on this. If you are really into the math and you've been disappointed that there hasn't been more math thus far, you're still going to be disappointed after these slides. In fact, I'm not even going to talk through all these individual bullets, but for anyone who's really interested in looking at a little bit of the statistical background or the mathematical foundation behind this, feel free to pause and browse these slides. One thing that I will note about the functional form here is that we assume that as someone becomes infinitely proficient, as their proficiency score goes to infinity, then the probability of them answering an item correct goes to 1. It becomes a sure thing. And in the opposite direction, as someone's proficiency goes to negative infinity, the least proficient you can possibly be in our domain, the probability of answering an item correctly goes to 0. All right, now let's look at some item parameters in the functional form in action together. So for an individual with a theta score of 0.7, the probability of a correct response to an item where the difficulty is 0.5 and its discrimination is 1.5 is 0.574. And you can see that we just plug in that discrimination parameter right there. We plug in the individual's ability level right there, the 0.7, and then we look at the item difficulty. This is basically how it works. And so if you get your item parameters, you get a person score, you can get probabilities right there. Now let's look at a few curves and bring it all together. So where do these curves come from? They come from this functional form, and they come from these item parameters that we've estimated. And so once we have these item parameters, we can pick a proficiency score, such as -1, and we can see that for an individual with a proficiency score of -1, you can see from the curve that they'd have a probability of a correct response of about 0.42. For the other item, we could compute by hand, or we can see on the curve that an individual with a proficiency score of -1 would have a 0.02 probability of answering the item correctly. All right, let's go back to the roadmap where we've been. We started off with the user experience on Khan Academy. Then we moved on to answering the question, why would intelligent tutoring software use IRT? In this video, we looked at interpreting item parameters, difficulty and discrimination. And in the last video, we're going to look at item parameters in action, how we take these items and build a test.